Good morning, guys. It's Thursday, November 13th, and we're getting ready to start geometry, and we're going to continue in Chapter 9 with reflections and symmetry. Today, we're going to focus on line, point, and rotational symmetry. I want you guys to watch the video, and when I told the video to pause, I want you guys to go ahead and pause, do the work that I've said to do, and then I'll either go over the work on the video or I'll have a copy of the answer key for Mr. Earhart to do with you. So like I said, we're gonna go ahead and get started with today's lesson, and hopefully you guys can follow along. Today you're gonna do reflection and symmetry. Tomorrow we're gonna do a review, and on Monday there is a test. So I need you guys to be fully involved and participating and asking questions to each other, and have questions ready to ask me on Monday when I get back. Okay, so the first thing we're going to talk about is line and point symmetry. A figure has line symmetry if it can be folded along a line so its two halves match. Now, you guys have studied this before. You actually did line symmetry probably even as early as elementary school. If I draw a line down a shape and I can flip this side over to touch this side and the two shapes are equal, then it is said that a figure has line symmetry. Okay? So there are 12 shapes here. There are 9 shapes here. I want you to go ahead, I'm going to pause the video, and then I want you guys to go ahead and give the video a look to see if you could correctly identify whether or not these shapes have line symmetry. So, and when you do that, you're not only going to tell me if it has line symmetry, but you're going to tell me how many lines of line symmetry it has. So if I'm going to do number 1 for you, and then you're going to finish 2 through 9, I'm going to draw a line here, and I'm going to draw a line here, and I'm going to draw a line here, and then here. And so this shape, and so if this is the first thing we're going to do, so this is the first thing we're doing, so I'm going to A. This shape has 4 lines of line symmetry. So go ahead and pause the video, take a look at the shapes, and determine whether or not they have line symmetry and how many lines of line symmetry each one has. When I unpause it, or when Mr. Earhart unpauses it, we're going to go over the answers together. Okay, hopefully you've taken about 3 minutes and you've looked at whether or not the shapes had line symmetry. Now, number 2 has 3 lines of line symmetry. And a key to determine whether or not something has line symmetry is if the point hits the midpoint, if the line hits the point of one angle and the midpoint of the opposite line. That's usually a pretty good inclination that that's where the line symmetry is going to take place. So for number 2, question A is 3. For number 3, I'm sure that there's some people who did these, and then they also tried the diagonal. But in this case, that's not line symmetry, because when I put it on the diagonal, and I'm just going to show you, when I fold this down, this piece comes down and hits this, but this does not come down and hit that correctly. Okay? And so the diagonal does not count. And so this square has 2 lines of line symmetry. The pentagon has 5. And again, the key is, does the line bisect the angle and the opposite side? Okay. This one has 2. Number 6 doesn't have any, because when I draw this, and if I pull that over to there, it's not going to match. Same thing there, Same thing there. They're not going to match when I pull down the other side. So number 6 was 0. Number 7. Number 7 just has 1. It's right there. Number 8 also only has 1. And number 9 also only has 1. Again, the key is, can I fold the shape and get the correct matching of the two sides? So hopefully by seeing my drawings, you understand more clearly what line symmetry is and how many lines of line symmetry a shape would have. Obviously, perfect squares, perfect polygons get the same number of line symmetries as points that they have. But if we have imperfect shapes like 3, 5, 7, 8, 9, and 6, then you get a little bit less. Okay? All right. The second thing we're going to do is we're going to move on. We're going to do point symmetry. Point symmetry is simply, can I turn the shape 180 degrees and the figure is the same? So if we come and look at number 1, arrow pointing up, arrow pointing down. When I turn the paper around 180 degrees, do I still have an arrow pointing up and an arrow pointing down? Yeah. I have an arrow pointing left, I have an arrow pointing right. Turn it 180 degrees, it does. So number 1, part B, our answer is yes, this does have point symmetry. So what about number 2? Give you guys a second to answer that. Does number 2 have point symmetry? Well, when I turn it 180 degrees, do I have the same image? Well, when it was turned the other way, the arrow was pointing up. Now the arrow is pointing down. It does not have point symmetry. I cannot turn it on its center and get the same shape. Take 2 minutes and do 3 through 9. Does it have point symmetry? Yes or no? Please pause the video. We'll have the answer. Okay, hopefully you guys took a look at this and determined whether or not these had point symmetry. And so number 3 ended up being no, or I'm sorry, number 3 ends up being yes. Number 4 ends up being no. Number 5 is yes. Number 6 is no. Number 7 is no. And number 8 is no. And number 9 is no. Now, number 9 is going to be a point of contention because people are going to say, well, here's up and up. But the problem is it has an obtuse angle going left and an acute angle going right. And when I flip it, I have an acute angle going left and an obtuse angle going right. So make sure, like I said, that you've taken a good look at flipping the shape to get the point symmetry. So we have line symmetry and we have point symmetry. We're going to add in one thing here, and that's rotational symmetry. Rotational symmetry is the number of degrees to turn the shape one time. So rotational symmetry is the number of degrees to turn the shape one time. Alright, so we've been talking about this all year, about how many degrees are in a triangle and how many degrees are in a circle. And you guys know that there are 360 degrees in a circle. So in any shape, there's 360 degrees outside of that shape. So the question is, how many degrees does it take for me to turn this shape to get it to face another direction? Well, for this one, I turned it a quarter turn. And so if I have 4 exterior points, I'm going to turn this 4 times. So the rotational symmetry for this shape is 90, 180, 270, and 360. For the triangle, there are 3 exterior points. So I take 360 and divide it by 3, and I get 120, 240, and 360. All 4-sided figures will have the same rotational symmetry as the square. So 3, 5, and 8, and 9 will all have a rotational symmetry of 90, 180, 270, and 360. All 3-sided figures will have a rotational symmetry of 120, 240, and 360. So 6, 7. What about number 4? How many exterior points does 4 have? Well, it's a pentagon, so it has 5 exterior points. So the rotational symmetry here is a little bit more difficult. 360 divided by 5. 72, 144, 216, 288, 360. So again, rotational symmetry is how many degrees does it take to turn the shape one time, and then until you get back to the beginning again. So I'm going to finish filling this out for these. This will be a study guide for you guys for tomorrow's quiz prep. Okay, so that covered line, point, and rotational symmetry for what we need to do for this section. Okay, to finish our review for this lesson, you're going to go to page 235 in your workbook, and you're going to focus on questions numbered 1 through 12. For 1 through 8, I want you to do what we just did there. I want you to tell me how many lines of symmetry. I want you to tell me whether or not it has point symmetry. And then finally, I want you to tell me if it has rotational symmetry. And you can just tell me the first angle. So if I'm going to do number 1, I'm going to say that it has 1 line of line symmetry. And I just showed that by drawing it. It does not have point symmetry, so I'm going to put no point symmetry. And then it does have rotational symmetry. 1, 2, 3, 4. It has 4 points of rotational symmetry, so 90 degrees to turn this to the point where it will be symmetrical again. Okay? So go ahead and finish 2 through 8. Mr. Earhart will have the completed page to go over with you guys individually when you are done. So bring your answers up to him to check. And make sure you can actually share them with a partner before you bring them up to be checked. Okay, the last thing I have for you to complete here today is a review of everything that we've done in Chapter 9. It's the beginning of your review for the Chapter 9 test. But just a quick hitter review so you guys know what to do. Just want to remind you that for reflections and translations, when you reflect around the x-axis, you change the y. When you reflect around the y-axis, you change the x. When you reflect around the origin, you change the sign of both. And when you reflect around the line y equals x, you flip the y and the x value. So giving you 4 problems where you practice that. So you have A, B, C, and you have to flip around the origin. So remember, you want to write down your A prime, your B prime, and your C prime points, so that when you put your picture in here, you should have 2 triangles. And again, just like we talked about, you might want to use a pencil and a highlighter or a pencil and a pen. or a pen and a highlighter, 2 different colors, so that we can definitely see the original and its reflection. Okay, and so number 1 practices the origin, number 2 practices the y-axis, number 3 practices the x-axis, and number 4 goes across the line y equals x. Problem number 5 talks about translating under the reflection x plus 2, y plus 3. Again, use 2 different things. Make sure you write down your J prime, your K prime, and your L prime point. And then in the picture, there should be 2 shapes. Okay, 2 shapes. Just another practice with that with number 6. And then finally, a quick review of line and point symmetry. How many lines of symmetry does each figure have? Does the figure have point symmetry, yes or no? And of course, give me the degrees of rotational symmetry. This is the last assignment that's due for today. I will be taking this up as a classwork participation assignment, this one only for Thursday. So make sure that you guys complete this fully, and we will, you'll be able to take it and look at your, Mr. Earhart's going to have the answers to share with you, but then you're going to hand it in on Friday, actually, because you're going to use this to complete your study guide for the test on Monday, and then I want you to hand this in on Friday, completely filled out, for a grade. If I do not get this on Monday, you will have...
Fred Henschel to the main office.
If I do not get this on Monday, then you will have a 0 for the class participation for the 2 days I was gone. So this sheet has to be turned in, completed, and I will be grading it for right or wrong, and that'll affect your participation points, because you'll have an opportunity to show it to Mr. Earhart, go over and fix anything that's wrong, to make sure you have a completed assignment ready for tomorrow. Okay? Hope you guys have had a great day. Hope you guys have a great day the rest of the day, and we will see you tomorrow.